Good evening, everyone. So, for today, we have this topic differentiation, and I've already told you my name. There is no one's commenting. So, all of you must be knowing my name, Krishvi Srivastav, and I teach you today differentiation. We have decided a workflow, and I'll let you know. I'm just waiting for other students to join. So, let's wait for them. Until then, I hope you have enjoyed the last video as well. The topic for the last video was functions. I covered the basic things about it and I tried my best to cover the maximum possible things in that 1 hour video. I hope you will like it, and if you have not watched it, then just go and watch it after this session. And also like, subscribe, and share my videos and share the Altered ME channel's video. I hope all of you will like it, and we are trying our best. We'll starting from the base and then we'll reach to the advanced level, so that we should cover everyone's perspectives and everyone's level. And I hope all of you will enjoy it. So let's wait for everyone and we'll start from 6. Okay, it is 6 p.m. So I think we should start now. Okay. So without any further delay, we're starting today's session, which is about differentiation. Differentiation. I know almost no, most of you have learned the basics about differentiation in your previous class, but it's my duty to let you know about the basics from day one. So this is our day one of differentiation, and this is the workflow I have decided for today's class. This is how we will go one by one, and we'll also solve some questions. So I hope you will like it, and I will also give you homework, and the homework will be of the basic questions. Like, you must be doing it. It is a cakewalk for you. So let me tell you the walkthrough of our today's class. So firstly, I'll tell you what is differentiation, because before studying anything you must know what is that topic which you are studying. So we'll study what is differentiation. The second thing will go geometrical interpretation of dy by dx. Then we'll go with the rules of differentiation. The rules means the basic formulas about the sum of functions, product, division, and how does it get solved. So these are the formulas. So it's not a rule kind of thing, it is more about formulas. And you don't need to learn everything. You will learn on your own when you will just solve so many questions, because differentiation is a topic you will study till your higher education level. So these formulas you will not need to learn, you will just learn it like in a reflexive way. Okay, so then we'll tell you about the differentiation of some functions. Then I'll tell you the differentiation of implicit functions. Trigonometric function, we also do some trigonometric and inverse trigonometric functions. I'll tell you the formulas of all these functions, and I'll solve the basic questions. We'll not go to the depth of trigonometric function differentiation, because that will be more for you for the first class. So I'll try to cover the basic and yet the things which you will, so after studying which you can say that yes, I know differentiation. So today's agenda is, if you cover this class you can say that yes, you know differentiation and you can solve its questions. If you'll solve the basic questions, I promise you will solve the advanced question as well on your own. So what we'll study first, this is the presentation I have made for you. So I'll choose the pen, black color. Okay, so now I'll tell you what is differentiation. Okay, so moving further, what is differentiation? Differentiation means the rate of change of one quantity with respect to another. Okay, so it is basically telling us the rate of change, meaning the rate of change of one quantity with respect to another, like dy by dx. This is how we write the differentiation of a function. Okay, so how does you say this thing, that differentiating this function with respect to? So when we are writing dy by dx, we say differentiating this function with respect to x. Okay. This is said as with respect to x, because here we are writing dx below, and if we are writing dx by dy, and in the bracket we are writing the function, so that is with respect to y. Okay, so how do you say it? Differentiating this function with respect to y. If you are differentiating any function with respect to y, then you will use d by dy. Okay, you'll write dy below in the denominator, and dx if it is with respect to x. Basically, uh, today we'll just do with respect to x. With respect to y comes in a more complex algebra, and that's not complex, but for your practice, initial practice, we'll just do dy by dx, right? Okay, so moving ahead, the maximum or minimum value of a function. For example, we take velocity and acceleration of moving objects, and the tangent of a curve are determined by differentiation. And if y is equals to fx, that is differentiable, then the differentiation, sorry, is represented as f dash x or dy by dx. I already told you dy by dx. This is how it will be present if the differentiation is with respect to x. Okay. So now what I've written here, velocity and acceleration of moving object. This is an example. Okay. So all of you must be knowing velocity. Okay. So distance by time is known as a speed. Okay. Now all of you know that how do you get the instantaneous velocity? We get by differentiating it with respect to time. We get by differentiating the distance with respect to time. That is how we'll, we will have a function of distance, and that we will differentiate with respect to time, and that will give us velocity. This is how you do it in physics. So we'll not go into depth of it. And another example, that is acceleration. Acceleration, what it is dv of dt. Okay, what is v? V is velocity. So differentiating it with respect to time, this is how we get this uh, acceleration. Okay, so this is what the example I told you. And now the another example, which is the tangent of a curve. Okay, the tangent of the curve, which is determined by differentiation. This is basically what it is. It is a geometrical representation of differentiation. Okay, because now I am telling you that we are differentiating with respect to x, then everything has a geometrical representation. Okay, so how do we get the tangent of a curve? Then that is I'm going to tell you in this geometrical representation of differentiation. Okay. Okay, so now this is what geometrical meaning of derivative is. Derivative, you know, right? Like differentiation, what is the derivative of this function? If we are saying what is the derivative of this function, that means we have to differentiate this. Okay, uh why is it l? Just a second, I haven't chosen a pen. So we have to write l here. Okay, it is secant line. The geometrical meaning of the derivative of y is equals to fx is the slope of the tangent to the curve y is equals to fx at x and fx. So I have drawn the diagram in the next slide, but here I'll give you a just brief of it by just showing it from a pen. That if I have to get a slope, what is slope? Tell me. If you, all of you have solved this, if we have these 2 points, x1, y1, and x2, y2. So how do we get the slope here? You must be knowing this formula. I assume this thing. Slope is equals to y2 minus y1 upon x2 minus x1. That is the slope of that line. You know, we used to do this in our junior classes. So this is how we get the slope. But I have to get the slope of that particular point. You know, the slope of the tangent of the curve, then how can we just get that thing? We just get that thing by drawing. Suppose this is the graph. Okay, suppose this is the graph. Then by drawing a tangent here, so how do we get the slope here? We get the slope if, sorry, I have to write this fx near the curve. So this is fx, okay? This curve which I have drawn is fx, and this is, I have drawn the tangent across this point, okay? And I have to find the slope. How do we get this thing? We get this thing which is differentiating this function. Easy, easy peasy. So we get this function by differentiating with respect to x d fx upon dx. We'll differentiate the fx function with respect to x, and this will give us the slope. That is what I've written here. That in the formula we see slope of a curve is the slope of the tangent at that point, and slope of that line is y2 minus y1 upon x2 minus x1. Geometrical meaning, if the curve is y equals to fx and the tangent is drawn, then slope will be differentiation of that function. Okay. Okay. I hope all of you have understood this geometrical representation. Uh, okay. So this is the graph I have drawn for you all to understand what I have told you in the earlier slide. So this is the graph. Fx is equals to x square. This is a graph of x squared. I hope all of you must be knowing this graph. I assume this. It is a parabolic graph. Okay. Now we have this function fx, which is x squared. Now slope of the secant, I have already told you what is this formula. See, this point I am taking it as second point. This point I am taking it as first point. Okay. Now see, y2 minus y1, which is fx plus h minus fx upon x2 minus x1. Okay. You see this? What is this formula? y2 minus y1 upon x2 minus x1. This is how I have written this fx plus h minus fx upon h. Now we have this thing, limit of h tending to 0 and slope of secant is equals to slope of tangent. So how do we do this? What I have written limit here, I must tell you this, that when we do this differentiation, okay, what is the actual differentiation? Limit is always tending to something which is given in that question. So how do we do this differentiation? We differentiate it with respect to x, and that is, I'll tell you the literal meaning of differentiation. It is exactly at that particular point. If we are talking about the differentiation of that function, that means exactly that point, not above that point, not below that point. When we do this formula thing, it is not the exact thing of that point. Okay. Differentiation is about the accuracy, so we use limit after that. Okay, so this is basically the geometrical interpretation of differentiation. This is how we do this. We use this thing, we apply the limits, and then we get the answer. And for our differentiating formula, we just use like differentiation with respect to as you mathematically, which you need to solve in the differentiation thing, that you will do the basic things right now. We use this limit thing. Okay, I'll not go into depth right now. We'll use this limit thing into application of derivative. There I'll tell you the in detail the use of limit and everything, and why do we use it and how is it done. We'll solve various questions there and you will get used to it. Okay. Okay, next slide. So here we have the rules of differentiation. It is not the rule, first of all, I must tell you. It is like a formula. Okay, now let me read it out for you. Power rule. This is one of the most common rules of derivatives. If x is a variable and is raised to a power n, then the derivative of x raised to the power is represented by d of dx xn, and that is nx n minus 1. What is it? X to the power n is equals to n x n minus 1. This is the power rule. Okay. What is the sum rule? If the function is sum or difference of two functions, then the derivative of the function is the sum or difference of the individual functions. What is it telling you? That if this is the function ux, okay, if vx is another function and it is written as ux plus vx or ux minus vx, let me tell you, here I told you about the product rule, power rule, sorry. So x cube is the example of this. So how do we solve it? 3, we write 3 here, x square. Okay, this will be the example of power rule. Now here we are writing the sum rule. What does it mean? Let me tell you an example. I have already told you about the power rule, so I can write here x cube plus x 6. Okay, so how do we differentiate this function? Tell me. This is what sum rule is about. We'll differentiate this function and this function separately. Okay, if I have to differentiate this function, I'll differentiate it separately. X cube okay. So what is the differentiation of x cube? I have solved above 3x square. X to the power 6, it will be 6x to the power 5. Okay. How do we get this? 6 is the n is written here. And for this, we get n minus 1 for the power. So 6 minus 1, 5. Okay. So this will be the answer. And this is what sum rule is. Easy, right? If there are two functions written in a, if it is minus, if minus is written in between, then we'll write minus in between. We don't have to do anything. We just have to separate the functions, okay? Whatever sign of the function is, it will remain the same unless and until the formula gets changed, okay? Sum rule, same thing. You can write it like, see, if it is written ux plus vx, then u dash of x plus v dash of x. If it is written ux minus vx, then it is u dash x minus v dash x. Okay. So what I'm telling you, minus one thing, it is x 5 plus, sorry, I don't have to use plus. I have already told you about the plus. So I'll tell you about the minus thing, okay? Minus 6x square. So what do we get here? It is minus. So how do we solve it? We solve it separately. It's the same thing. X to the power 5 differentiation 5 x to the power 4. Now minus 6, it is 2 only, okay? So we'll write minus 6 is the constant, we'll take it out. X square, how do we get it? 2x. What is the differentiation of x square? We get 2x, okay? So now, and if it is a constant, then we just put it out. 6 is the constant, in the 6 is square. We put it out 6. X square is left. X square differentiation 2x. Now what is the answer? What is the final answer? 5x to the power 4 minus 6 to the 12x. Okay. This is our final answer. I hope all of you have understood this rule now more clearly. Plus, minus, everything I have used. I have also used this constant thing. Constant you have to put outside. This should be crystal clear to you. Okay. Can we move ahead? Would you speak in Tamil? Tamil. Okay. Crazy Narendra. Crazy Narendra, I don't know Tamil actually. I would have loved to speak in Tamil, but I don't know Tamil, so I'm very sorry about it. I hope you know English, okay? So cope up with me and learn an English. Okay. So, this is a basic thing I've already told you. I don't need to tell you it again, but okay, let me just make it easier for you. X to the power 5. How do we get this? Derivative of x to the power 5. Derivative of x to the power 5, what does it mean? D by dx. We write x to the power 5 in the brackets, and then we get this differentiation 5 x power 4. Easy, right? How do we get this? It is x plus x cube. What is the differentiation of x? What is the differentiation of x? It's 1. D by dx of x plus d by dx of x cube. We get it as 1 plus 3x squared. Okay. Differentiation of x. If we have to differentiate d by dx of x, it will be 1. Okay. If we have to differentiate d by dy of y, then we'll get it as 1. Whatever it is, if it is like this, we'll get 1. Okay. What is the differentiation of a constant? The differentiation of a constant is 0. Okay. So let me put this question. Differentiation of constant. This is 0. Okay. Example, d by dx of let me take 23. 0. 23 is a constant. Okay. uh d by I don't know if it's visible, so let me write it somewhere else. So d by dx of Eleni, what is it? What is this? 0, because it is a constant. Okay. How do we see this as a constant? It has no variable x in it. Okay. So this will be a constant. That is how you decide constant. If the function does not consist x, if we are differentiating with respect to x and that it does not have x, then it's a constant and we just put it 0. And if it is written with some function, then we put it outside and differentiate that function and multiply it. Okay. How do we do this? I have already told you in the slide, in the previous slide. What is it? 6x squared. How did you solve it? 6 is a constant. We took it out. 6. We differentiated x squared. 2x. We multiplied 6 into 2x. That is 12x. Are we clear? Yes, we are clear. So, Ekantra just said move ahead. Yes, I am moving ahead. Thank you. And Crazy Narendra has said that, yeah, he knows English. Okay, very well, very good. Now you can learn from me. I can teach you. This is product rule. According to the product rule of derivatives, if the function fx is the product of two functions, ux and vx, then the derivative of the function is given by fx is equals to ux into vx, then f dash x is the representation of differentiation, is equals to u dash x into vx plus ux into v dash x. I know you must not get this thing. Okay, how do we represent that see, fx is equals to x squared and we differentiated x squared 2x. So this is the differentiation function f dash x. Okay, if we differentiate this again, then how do we write it? F double dash x is equals to 2. The more times we differentiate this, the more dash we put it. Okay. Okay. What is the product rule? What is it telling? Product rule is telling we differentiate first function, then multiply the second function. Plus, write the first function, then differentiate the second function. This is a product rule. Example, see, this is an example. X square, x plus 3. We are applying product rule here. Okay. Now see this, it's very easy. Now here, what is ux? Ux is x square, x plus 3 is what? Vx. Okay. So, we are differentiating ux 2x into x plus 3. What is x plus 3? X plus 3 is v of x. V of x is written here. Okay. Plus u of x. U of x is what? X square. What is v of x? X plus 3. Differentiation of v of x. 1. Okay. How do we do this? X differentiation of 1 plus differentiation of 3 is 0. I already told you the differentiation of a constant is 0. So this is how we did it. 2x into x plus 3 plus x square. Now just solve it in a algebraically way, which you do it in your junior classes. 2x into x plus 3 plus x square into 1, which is x square. Then 2x square plus 6x plus x square, which is equals to 2x square plus x square, 3x square plus 6x. Okay, this is our answer. It is very easy. All the basic things I'm telling you. We'll move ahead with more advanced questions. So the basics should be clear because you know many of you don't remember this product formula. When you're solving the advanced questions, when you're solving difficult ones and you don't know the formula, then how do we do that? We have to go back and learn the basic thing. So just make your basics clear from initial stage. Okay, from the start make yourself clear all the basics. Don't take it like, oh, this is easy, I know this. No, 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 just learn this thing, just solve everything so that you will remember, so that everything just goes to your subconscious mind and you don't forget anything. Moving ahead, taking the color of the pen black. Quotient rule of derivative. So this is the quotient rule. If fx is a function which is equal to ratio of two functions ux and vx such that fx is equals to ux upon vx, then as per the quotient rule, the derivative of fx is given by f dash x is equals to u dash x into vx minus u of x into v dash x upon vx square. Sania Moore is saying, ma'am, what are you teaching? I'm teaching you the class 1 of differentiation. I'm telling you about all the basics. I'm teaching you the basic functions, basic questions also I'm doing with you, and all the rules, all the formulas I'm going to tell you so that you can say at the end that yes, you know differentiation and you can solving some actual questions of differentiation. Okay, this is the base class for your differentiation. I hope I have answered you well. Sorry, I'm really sorry. I'm really sorry for all those who have used earphones. I'm very sorry. Find the derivative of x upon x squared plus 3. So here is the example. X upon x squared plus 3. We have to differentiate this function. D by dx of x upon x squared plus 3. Just use this formula and you will like get used to it, and you don't even need to remember this formula, and you'll just do it like in a second. So let's do it then. What is ux here? X is ux. What is vx here? X squared plus 3 is the vx. So how do we do this? Differentiation of ux, that is x, is 1. Vx, x squared plus 3, differentiating it. X squared, 2x, 3 is a constant, so it's 0. So this is the differentiation of vx minus u of x is x, v dash x, x squared plus 3, which is 2x. Okay, I did a mistake. I didn't need to differentiate it here. I don't know. I just zoned out, I guess. So x squared plus 3, we are just going to write vx here. Okay. Upon x squared plus 3, which is vx. So we'll just do it x squared plus 3 whole square. Now you just need to solve it. Only algebra is left here. X to x square. And we'll write x squared plus 3 whole square. X square minus 2x square minus x square plus 3 upon x square plus 3 whole square. This is our answer. I know many of you have known this thing. Okay, let me take another example for you all. Okay, let us erase all the ink on the slide and write it again. So let's take this example of okay. So this we have done. I've solved this example. I'm taking another example. Let me write a question for you all. X cube plus 2x upon 3x 4, no, 3x squared plus 5. Okay, this is the question. Now we're going to solve this thing in a faster way. Ux Vx. Okay, this is our formula, and now we're going to solve this thing. First of all, what is the formula? Vx squared is the denominator. So Vx 3x squared plus 5 whole square. Vx squared. Okay, now u dash x. We have to differentiate the numerator first. How do you remember this formula? Whenever there is numerator on denominator, differentiate numerator into denominator. Plus, we have differentiated the numerator, right? So differentiation of numerator into denominator, then minus numerator, and then differentiation of the denominator. We have to differentiate numerator and denominator in one go. Okay, if we have differentiated the numerator, then we will not differentiate the denominator. And firstly, we have to differentiate numerator, then in the second one we have to differentiate the denominator and put the minus in between. Simple. So now differentiation of numerator, that is 3x squared plus 2. I've already told you how do we differentiate this into denominator. Minus numerator x cube plus 2x, differentiation of denominator 6x, and 5 is a constant of 0. So this will be the differentiation. Now we just have to solve it algebraically. I know all of you must be knowing this, but let me just complete the question. Okay, 3x squared into 3x squared, 9x to the power 4 plus 15x squared plus 6x squared plus 10 minus 6x to the power 4 plus 12x squared, 3x squared plus 5 whole square. You have to use that whole square formula and just open the brackets. X to the power 4, x to the power 4, 9 minus x, 3x to the power 4, okay. 15x squared plus 6 squared, 21, 21 plus 2, no, 21 plus 12, sorry. 33x squared. What is left? Plus 10. Okay. 3x squared plus 5. Open the brackets. What is it? 9x to the power 4 plus 25 plus 30x squared. This is our answer. The question. See it once. This is how we solve it. Okay. I have solved second question of the derivative rule, of the quotient rule of derivative. Okay. First we have done. This I have already told you. This was the basic thing, and here it was a bit complex about the powers, and also I used some numbers and constant as well. So moving to the next slide. This is the formula for trigonometric functions. These are all the derivatives. I have used this example for you all. This is inverse trigonometric function, and this is the implicit functions, and then we'll just do some questions. Okay. Okay. I told you about all these things. About differentiation of a constant is 0. Whenever it is a power thing, I have told you the formula, sum, difference, everything I have told you. Okay. Now we'll see what is the formulas for this trigonometric function. I know all of you must be saying like how do we learn it, but don't worry, you just learn it like easy. So differentiating sin x, it will give cos x. Let me select the pen. Differentiation of sin x is cos x. Cos x minus sin x. You see, sin x, just remember, sin is cos x. So cos x minus sin x. Tan x, sec squared x. Cot x minus cos x squared x. Sec x tan x, cos x minus cos x cot x. Sin h x, cos h x. Whatever it is written in this thing, you know. sin hx, cos hx, tan hx, h square x. These are all the formulas for you all, and I know you will learn this very, very, very obediently, and will solve the trigonometric function, and then you will just learn it like in a cakewalk, and this will help you with solving the questions in a faster way. Okay. Sec x tan x, cos x, minus cos x cot x, sin hx, cos hx, cos hx, sin hx, tan hx, sec x square x, cot hx minus cos h square x, right? Minus cos x square x minus cos h square x. Sec x tan hx minus cos x minus cos. Okay, okay, we are good here. Moving to the next slide. How do we do this? It is using the derivative rule of when there are two functions, the sum or difference is given, and it is using the formula of trigonometric functions. Okay. Cos 2x, cos 2x is what? It is not cos x. We know the formula for cos x. Minus sin x. Okay. For cos 2x, minus sin 2x. But this 2x is not x. So how do you solve this thing? What in differentiation, what you do is you solve the function, and then what is written in that function, we can differentiate that function and multiply with it. D by dx of 2x, okay, minus sin x. What is the differentiation of sin x? Cos x. Okay, so how do we do this? Minus 2 sin 2x minus cos x. Differentiation of 2x is 2. Okay. So minus 2 sin 2x minus cos x. This is the answer of it. Tan x plus 1 by 3 tan square x. What will be the differentiation of this? Oh my god, my writing. Stay with me, guys. I'll improve my writing soon. I'm telling this to my man from class 3rd. Tan x plus 1 by 3 tan square x. Again, how do I am writing this x? Writing the x in a very proper way. Let us put it right. X. Okay. Tan x plus 1 by 3 tan square x. So we are differentiating this function now. D by dx with respect to x. Okay. We are differentiating this function with respect to x. What is the formula for tan x? I told you. Tan x. Remember. Sec square x. Okay. Sec square x plus 1 by 3 tan square x. 1 by 3 tan square x. What is 1 by 3? 1 by 3 will take it out. What is left? Tan square x. D by dx of tan square x. Am I good here? Are you guys getting me what I'm trying to tell you? So sec square x plus 1 by 3 dy dx of tan square x. How do we solve this tan square x? We solve it by 2 tan x sec x. Okay. Shit, I just told you the answer. Tan square x. How do we do this? Tan square x. So we write 2 tan x. Okay. Because you know x to the x square. What is it? 2x square. We'll use it like that. Now tan x differentiation of tan x. So sec square x plus 1 by 3 2 tan x dy dx of tan x. What is the tan x formula? I told you. I've written here, right? Sec square x. So this is how we're gonna do this thing. So let me just put it in whole answer form. Sec square x plus 2 by 3 tan x sec square x. This is our answer. Sec square x plus 2 by 3 tan x sec square x. Are we good here? Do you understand this thing? You're sure? Because I'll give you the homework and then I'll ask you all these questions in a different way. It will be easy, okay? I hope all of you do it. Now we are using this differentiation formulas for inverse trigonometric functions. Sine inverse x, what is it? Minus, no, we don't use minus here. 1 upon under root 1 minus x squared. Cos inverse x minus 1 upon under root 1 minus x squared. Tan inverse x 1 upon 1 plus x squared. Cot inverse x minus 1 upon 1 plus x squared. Sec inverse x 1 upon x under root x squared minus 1 x is a mod. Cosec inverse x minus 1 upon mod x under root x squared minus 1. So these are basically 6 formulas. Okay, how do you want to remember this thing? Remember it like that. Remember 3 formulas and then another 3 are the minus of that thing. You are using sine inverse x. What is it? Min is equals to 1 upon under root 1 minus x squared. Cos inverse x minus of that minus under root 1 minus x squared. Simple. You just learned it. Tan inverse x 1 upon 1 plus x squared. Cot inverse x minus 1 upon 1 plus x squared. Sec inverse x 1 upon x under root x squared minus 1. And what is cosec inverse x formula? We just have to write minus again. So just remember like that. Sine, cos, okay. Tan, cot, okay. Sec, cosec, okay. How do you say? Sine 1 upon under root 1 minus x squared. Cos minus 1 upon under root 1 minus x squared. So remember these formulas. 1, it's a negative of it. It's a negative of it. Okay. Remembering 3 and applying the common sense for the other 3 and you are good to go. So these are some formulas. A to the power x. How do we solve this thing? E to the power x. E to the power x log a. Okay. Log a, you know what is ln a? Log base ea. Okay. E to the power x, what is the differentiation of this? E to the power x. E to the power x does not change. Differentiating of e to the power x, it will only say e to the power x. Log a of x, a is the base here. Okay. So what is the answer here? Ln a into x. This is how we just did this. I'm writing this formula. And what is the formula for log base ex? That it is 1 upon x. So you know, I'm just writing it. Ln x log ex. So differentiation of this is 1 upon x. Okay. And okay. So I told you this. Now let me put it like this. What will be the differentiation of this function? Tell me. Let's do it then. See, we cannot write this 1 upon 3x. Why? Because the base is 10 here, okay? So, you know what is base? Log AB. You know this formula? Log B upon log A. This is a log property, right? This is log property about the base. So, if I have log base 10 3x, so how do I write this thing? Tell me. Log B, which is 3x log 10. This is base C, this is base E. And we'll just differentiate it. Just take out the constant, which is log 10. Then differentiate log 3x. Log 3x, what will be the differentiation of log 3x? Log 3x, 1 upon 3x. And we'll multiply the differentiation of 3x also, because 3x is not x, 3x is another thing. So we'll multiply it and then we'll get 3. What is 3x log 10? Okay, so I have solved this. Log 3x, and this is how we do it. So log 3x formula 1 upon this and this. So this is our answer. And now I told you about a to the power x. A to the power x formula will be a to the power x log a. This is what this formula is telling us. So if we get a to the power 5x, then what is it? A to the power 5x into log a. And what is the differentiation of 5x? 5. This is our answer. Whatever the differentiation of the function which is inside that x thing, we have to multiply it. Okay. Okay. Somebody has retracted his message. I don't know. Now this is the chain rule. Chain rule, basically I'm telling you it is like that only. I told you what is the differentiation of that function which is contained in it. We'll just multiply it. So this is like a formula which they have given. But what I am telling you, if you will remember like that, you are gonna rock. So it is dy by dx, dy by du into du of dx. So basically dy by dx, we can write it, if we differentiate dy by with respect to du is another variable, and differentiating du with respect to dx, then it is the same thing. Okay, du, and in place of du it can be dv, it should be the same. Du dy by dx is equals to dy by dv into dv by dx. Okay, same thing, right? So I think this is very good to go, and you just you're gonna use this in formulas, you're gonna use this in limits, you're gonna use this in application of derivatives. This is very basic class for you all, and you must know all these things for all the questions which you need to solve. Okay, uh, if you think that without knowing all these things you can do things in the other chapters, no, this is the first chapter you need to study for other all chapters. Okay, now we'll solve some questions. Compute the derivative of x upon 1 plus tan x using the differentiation rule. Let me select the pen. I've also prepared a homework PDF for you all, and I'll put it over there. So you will only need to solve that questions. These are very easy questions, and I hope you will solve them. I'll give you a hint. I'll make a video also about it. X upon 1 plus tan x. We are differentiating it with respect to x. We'll use the rules here. Initially, we'll use the rules so that it clicks into our mind in a second. After some days, we'll without talking about any rule, we'll just get the answer like this. Okay. So using the differentiation rule, how do we? What did I tell you? First of all, denominator 1 plus tan x whole square. Okay. Now differentiating the numerator. Differentiating the numerator 1 plus tan x minus x d by dx of 1 plus tan x. D by dx of x, 1. 1 into 1 plus tan x, same thing. 1 plus tan x minus x. See, I told you here, right? Where did I tell you x differentiation? D by dx of x is equals to 1. I told you all these things. Okay, whatever is written with respect to, and if it is written the same thing, the value will be 1. Here we were. D by dx of 1 plus tan x. D by dx of 1 plus tan x. What is 1? Tell me. First of all, it is 1 plus tan x. So this is sum. So we'll solve d by dx of 1 plus d by dx of tan x. D by dx of 1, what is it? It is 0. 1 is a constant. D by dx of tan x. I told you the formula of the trigonometric functions. There it is written sec square x. So remember this thing, differentiation of tan x, sec square x. Just say it like this only, okay? Then only you can solve the questions in a very speedy way. People think that how can if you're sitting with a group of people and one person is answering questions very frequently, then you are like asking how do they solve it like in such a speed, because his basics are very clear. He knows the formula, he gets the formula in a second. Meanwhile, you're searching that formula, he knows that formula, he's writing that formula, and he's getting the answer. Seconds matter. Seconds matter. 1 plus tan x minus x into sec square x upon 1 plus tan x whole square x. Solving this to get the answer, 1 plus tan x minus x sec square x, opening the bracket, 1 plus tan square x plus 2 tan x. Many of you must be saying 1 plus tan square x, you can write anything. What is the need? What is the need? We can't do anything. Strategy. This is the answer. If I have to match options, then I'll just think about substituting anything. But I have to tell you about the way we solving this question. So I think this is it. Another question. Differentiation of e to the power x sin x. This can be two things. Let us solve both. E to the power x into sin x, and we'll solve e to the power x sin x. Solving the both. So here we have to use only the product rule, right? E to the power x sin x. So what do we do here? Differentiating e to the power x. Same thing, e to the power x does not change. I told you the formula. Sin x plus e to the power x, differentiation of sin x cos x. Okay, this is the formula I told you 2-3 slides back. I hope all of you have remembered this. So this is our answer. It was very simple. Now, e to the power x sin x. This is a function inside function. So, first of all, just assume x sin x as x. E to the power x sin x, differentiating it with respect to x. Differentiating it with respect to x. What does it give? E to the power x sin x. E to the power x, differentiation is e to the power x. Then we'll differentiate x sin x. Okay. Now we'll multiply the differentiation of x sin x. This is what I'm telling you. Whenever there is a function inside function, we'll multiply the differentiation of that function. Okay. E to the power x sin x, e to the power x sin x, because e to the power x differentiation e to the power x. Then multiplying the differentiation of x sin x, which we are going to solve it. And I know you must know this. I have solved a lot of questions about it now in this class only. X sin x. Oh my god. I got scared. X sin x. So differentiation of x sin x. X differentiation is 1. So into 1 into sin x. Wait. E to our x sin x. Differentiation of x sin x. 1 sin x. Just cutting it. E to the power x sin x. Differentiation of x sin x. X differentiation is 1. 1 into sin x is sin x plus x differentiation of sin x. What is it? Cos x. Okay. So what is the answer? E to the power x sin x plus x cos x. See, these were two questions, and this is how we solved it. Here we only use a product rule, and here we use the function. If I'll put it like this, if I have this function as f of x, if this is e of fx, then How did I solve it? E of fx into differentiation of fx. This was a basic thing, and here I followed this and I did this thing. Same goes for all the questions which I have said, that if there is any x thing present here, then we'll just write it like in that formula and then multiply the differentiation of that formula. Okay, I think now we are good to go and our class is over. I hope all of you have enjoyed it. So like, subscribe and share and keep watching.
Great.